Let's rock on the second question here. See if we can use all of the stuff that we learned in the last one. Oh boy, you got your scrap piece of paper? Yep, I do too. Remember, you got this guy here. You can actually go out and factor this guy through inspection again. So you're going to get x minus 4, right? X minus 3 over, aha, look at that. I love these guys. Yes, difference of squares. Those are so much fun. X plus 3, X minus 3. And lo and behold, as soon as you factor this, guess what you see? Yup, the point of discontinuity. Where does it come in? Well, X has to be 3 for a point of discontinuity. So guess what? There's our value here of 3, right? Substitute that back into the now canceled equation, which is what's left here, x minus 4 over x plus 3. That's what's left. Substitute that value of 3 back in here. Put it into here, put it into here, watch what happens. This will give you 3 minus 4 over 3 plus 3. 3 minus 4, of course, is minus 1. 3 plus 3 is 6. So there's your y. There's your point at 3 minus 1 over 6. Whoa, make that look like a 6. There it is. Perfect. Now, we can go on to the rest of these things. Again, I'm going to just get rid of this because I don't need it anymore. And let's go right into the rest of it. We can go and take a look now and find out our vertical asymptote. Our vertical asymptote is right there at x equals to minus 3. Remember, if they cancel, it's a point of discontinuity, but don't forget, you have a non-permissible value here of x cannot equal to minus 3. So our vertical asymptote, in fact, is at x equals to minus 3. Know the difference between a non-permissible value, which you would write as not equal to minus 3, and an equation for the vertical asymptote, which you would write as x equals to minus 3. Oh, keeping everything sorted is a pain in the butt. Yes, I know. But now, here we go. Let's go and find out that, the horizontal asymptote. Look what you have left. X minus 4 over x plus 3. There's the two that match, which means it's a 1 over 1. So your horizontal asymptote here is at y equals to 1. Oh, how beautiful. X-intercept. Do you remember x-intercept? You only had to worry about the numerator. Why? Do you remember why? This is the thing that's so crucial. Because in an x-intercept situation, y equals to 0, which means this is 0, which means this would be cross-multiplied, that would be cross-multiplied. 0 times anything down here doesn't matter. The way you determine your intercept, of course, is with the top one. So this is x minus 4 equals to 0. So guess what? X equals to 4. And that's just because our y equals to 0 and our denominators cancel out. Okay? So x equals to 4 is your x-intercept. Oh, how incredibly beautiful is that? Y-intercept now. A little bit tougher to do, but here we go. Let's clean this guy up. Let's go back to our original canceled equation. Okay? Our original canceled equation, which was x minus 4 over x plus 3. That's what y equals to. Now, remember, if you're looking for the y-intercept, x is 0. That's gone, leaving you a minus 4 on top. That's gone, leaving you a 3 on the bottom. There's your y-intercept. Your y-intercept, of course, is going to be at minus 4/3. Okay, so now we can start doing domains. Have you noticed that I've never erased this equation after I figured it out? I even left the canceling of the point of discontinuity in there. I left it because that helps us figure out the domain. So think about it. The domain then is all the values of x such that x cannot equal to, look at this, your non-permissible values. In this case, minus 3, and in this case, plus 3. So you can put down x cannot equal to plus or minus 3, but x can be any other number in the real number system. Oh, how pretty. How pretty. Let's go now to our range. Same thing. Our range here is that y such that y cannot equal 2 again. Think about it. You have an asymptote, so y can't equal to 1. Well, that makes sense, but you also have a point of discontinuity, which means y cannot equal to minus 1/6. Okay? Y can be anything else it wants to be, though. How pretty is that? There you go. And that's how you do this. I got one left for you after this mess, and I think you'll really, really enjoy it. Okay,